Okay, we're going to do the heat transfer lab. We're going to veer a little from the suggested procedure. I have water boiling in the kettle, which I will be pouring into one of the styrofoam containers. The other container, I will be pouring ice water in there minus the ice. I don't want the ice in there. If you leave the ice in there, it's going to affect the temperature because all the energy will go into melting the ice and not allow the temperature to rise. So what's going to happen is I am going to be putting my water in the two containers. And then I have to take the aluminum bar and put the aluminum bar into the top of the lids. And then each lid also gets a metric thermometer. So we're going to be reading in Celsius. So we're going to read the temperatures every minute for 30 minutes. So what I'm going to do is I'll get this started so you understand how to set it up. I'll get this started. I will record the temperatures for for 20 minutes. Every minute for 20 minutes in the hot container and the cold container. And then I will take a picture of that and post that for you. And yes, you guys are going to have to do the graph. And then you are going to have to share the graph with me when you write up the lab. All right, so again, little change. It's not room temperature. It's hot water versus ice cold water minus the ice. Okay, be back in a minute. All right, since we last talked, I put the hot water, filled the hot water in this container up to here. Put the lid on it. If you look at the thermometer, remember we're going to be reading the Celsius side. All right, the one over on this side, I put the cold water in, and we're going to read the thermometer. So every minute for 20 minutes, we're going to read the thermometer. We're going to read the thermometer and figure out how the temperature has changed. The aluminum bar is your vehicle for conduction. So molecule by molecule of the water is going to transfer from the hot through the aluminum bar to the cold. So the hot should be losing heat, while the cold gains heat. Energy travels from high energy to lower energy, or higher temperatures to lower temperatures. The aluminum bar is going to be our vehicle of conduction. If you guys were here, what you'd find out is eventually the aluminum bar, if you touch it, it's actually hot to the touch. All right, I'll have my data for you in 20 minutes. All right, 20 minutes has elapsed, and here's the data. Notice that the cold took a little longer to heat up than the hot to lose. If I'm looking, one question for you, did the hot lose as much as the cold gained? In order to figure that one out, you'd have to do a little quick math. You went from on the hot to from 83 degrees to 74 degrees, a difference of 9 degrees Celsius. So the hot lost 9 degrees Celsius and the cold gain went from 9 to 15, so it gained 6. So question, if the hot and the cold did not lose and gain the same amount, where did that energy go? Because it's insulated. So it wasn't going out into the environment. What was happening is some of the heat was being lost to the aluminum bar. The aluminum bar was our source of conduction, as I told you before. So molecule by molecule, you had to heat the aluminum bar up in order to then heat the water that was touching the aluminum bar in the cold container. So it took a little longer. Also, with that one, if I made the aluminum bar longer, how would that affect my rate of change? would the hot change more, or would the cold change more, or would the cold change less, or the hot change less? Every once in a while, you would find that as a question on your regents. And the whole idea is, since this is not insulated, that's why you're losing heat. But if you elongate it, it gives more surface area for you to lose heat to. So if I had elongated this aluminum bar, that means that your cold would have changed less, because more surface area exposed to the atmosphere, and since it's not insulated, you would lose even more heat. All right, hopefully this helps. If you have questions on the lab, let's look at the questions really quick. So guys are gonna graph. Notice your highest value is 83 and your lowest value is 9. So I started at 0, went up by 5s, got you up to 85. So I need 2 line graphs, one for hot, notice you're not starting at 0, from 1 through 20 minutes. So you're gonna have the hot is gonna be declining for the 20 minutes. Cold, do a different color, different circles, do a different pattern, something. Cold is going to be increasing for the 20 minutes. So 1 through 20, you got a line graph for the cold going up and a line graph for the hot going down. Now, if you look at your data, it did not lose or gain heat at constant rate. If it was at a constant rate, what you should see is straight lines. You're not going to have straight lines. Let's look at your questions. During the investigation, what kind of temperature change generally occurred in the hot container? Did the hot container increase in temperature, decrease in temperature, or remain the same? Same thing with 1B. Did the cold heat, did it gain? Did it lose or remain the same in general? Number 2, which container apparently lost and which container gained heat? Kind of went over that one. 3A, how did the rate of heat loss or gain change as time passed? Rate of change, you're looking at the slope. So if you look at your slope, once you have it done, it's not a straight line, so it was not constant. Why do you think this occurred? Because it took some energy to move through the aluminum bar. What direction the heat apparently flowed between the 2 containers? I already talked about that. You just gotta watch the video. How do you think that all the heat lost by one container was gained by the other? How can you tell? Why do you think this occurred? We already talked about that. Number 5, what conditions caused the flow of heat you observed? All right, we talked about that earlier. So you're always going to flow from high energy, which was the hot container, through the aluminum bar to the cold container, low energy. So high energy to low energy. How do you think the data of this investigation would change if you repeated it exactly but did not use the heat transfer bar? So if I had the styrofoam containers, if you ever put something in styrofoam container like ice, it takes a lot longer for your temperature to change. So you'd eventually get back to room temperature, but it's going to take longer for both of them, the hot one and the cold one. All right, good luck. If you have questions, email me. Remember, not only do I need the lab written up formally, but I also need a picture of your graph. Make sure 2 line graphs, label which one's hot, which one's cold, and you can give me a color key, or you can give me this one is circles and this one's triangles, whatever you want to do. All right, look forward to getting your lab. Goodbye.